In the previous videos, we will learn about the rotational matrix. Now, in this video, we will study the rotational operator. So, let's start. First of all, we have frame A. XA, YA, ZA are the axis of this frame, and O is the origin. And we define a point in XY plane, and its components in this frame is QXA, QYA. Means our QZA plane is constant. After that, we just rotate this frame with an angle theta. So that's why the new generated principal axes are XB, YB, and ZB. And ZB and ZA are coincide with each other. But the components of these planes in B frame is different from the components of defined in frame A, and these are the different components XB, QXB, and QYB, but location of this point in space remains constant. Just its expression in frame B is different from the expression in frame A. So after that, we just resolve this qy component along two directions, which are along the xa and ya, and we get the resolution components of qyb as qyb cos theta, qyb sin theta. Means we just convert the components defined in frame b into frame a. Similarly, we resolve the QXB component along XA, YA. Thus, we get the projections of point components in which we defined in frame B in frame A. So then we get these expressions: QXA is equal to the QXB cos theta minus Q by V sin theta. Similarly, we get QYA is equal to the sum of QXA sin theta plus QYV sin theta, and our QZA ZB are remain same because ZA and ZB are coincide with each other. And in matrix form, these equations are written in this way: QXA is equal to QXB multiplied by cos theta, QYV multiplied by minus sin theta, and there is not any z components, that's why it's equal to 0. And similarly, QYV is equal to sin theta multiplied by QXB plus cos theta multiplied by QYV, and this is 0 because there is not any z component. And our last row is QZA is equal to 0 0 because there is not x along XB and YV component, and ZB multiply 1, and thus we get this equation in the point defined in frame A is equal to the rotation about Z axis by an amount of angle theta multiplied by this point components in frame B, and this is known as rotation about Z axis of frame A by an angle theta. Similarly, we get the rotation about x axis by an angle theta, which is denoted by r x theta as equal to the matrix 1 0 0 0 cos theta minus sin theta 0 sin theta cos theta, and rotation about y axis by an angle theta is equal to r y theta cos theta 0 sin theta 0 1 0 minus sin theta 0 cos theta.